Hello and welcome to the first episode of Numbers with Nando. So you're a school teacher, you've just given out a test. It was a test out of 10 and you got 9 students in your class, and here are their test scores here. Now more important than the test scores is of course the fact that this was an ethical assessment. You used it to improve the learning of the students. You found out things they know, things they could work on, people who need to be extended, people who need to catch up, and of course that's the first thing you're going to do with your assessment. Help yourself become a better teacher and help them learn better. But after you've done that, you're going to do some statistics to see what else you can learn about it. Alright, learn about your classroom. So, first interesting thing to know about your class is, how did the middle person do? So, we've got 4 people over here, and 4 people over here, and so the middle person is here. The middle person is called the median. So the median score is 5. And that's all very well and good. But if you just said, hey, yay, my median person's 5, that doesn't really capture the fact that some person only got 1 and some other person got 10. So we also need to look at the spread of our data. So we're going to also capture the minimum and the maximum, 1 and 10, and to be able to make a box and whisker graph which captures the spread. We also need our lower quartile, so it's halfway between the minimum and the median, so let's jump in. Jump. Cool, we've got to 4. This is the lower quartile mark. And from the median to max we'll jump in. Oh cool, lands right on 7. So this is the upper quartile. Now to make a box and whisker graph, we'll just make a line to plot on. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our median was 5, so I'll draw a little line here. The lower quartile was 4. Upper quartile was 7. So that's my little box for the box and whisker. The minimum was 1, so I can draw 1 whisker here. And the maximum was 10, so I can draw another whisker here. So this is our box and whisker graph. And the significance of this is that 25% of your class is in this range. 25% is all crammed up in this little box here. 25% here is a little bit more spread out. And 25% is really spread out over here. So what we can see from that is that a quarter of the class is all jammed up here between 4 and 5. And if we look back at our data, that's accurate. 4, 4, 5, 5. Huge chunk of our classes is right there. And we can see that some people got 10 and 1, but not many people, because these lines are quite long, so only 25% of people are spread out all the way from there to there. So that is the point of the box and whisker graph. Now you're allowed to do this kind of stuff, medians and all this jazz, if you've got ordinal data. So ordinal data means that your numbers are all in a row. So if someone got 4, they did better than the person who got 1. If someone got 8, they got better than the person who got 7. And so you're allowed to do this kind of stats. Alright, and then that's really the only kind of stats you're allowed to do for ordinal data. So what we're going to look at next, I'm about to rub it off, so pause the video if you need to have a look at it. And I'm just going to check that this camera is still aligned before I move on. Yep, that's looking good. So, if we've got interval data, this means that it's just as hard to get from 4 to 5 as it is to get from 7 to 8. Same gap between the numbers, same amount of learning or performance was involved. So if you've got interval data, you're allowed to do some more interesting stat stuff. And the first interesting stat stuff, we're going to find the mean of the class, which is typically what people mean when they say the average. So the mean is the total score. That's of all your class added up together. Add up all your class and divided by the number of students. So let's add up the total score. 1 plus 1 plus 4 plus 4 is 10. 15, 20, 27, 35, 45. And as I already said, we've got 9 students. 1, 2, 3, 4, 5, 6, 7, 8, 9. 45 divided by 9, pause it if you need to, is 5. So our mean is 5. And I'm just going to make a little note about that here. The mean equals 5. Alright, I'm just going to rub out this working here, so pause it if you need to. Okay, now I'll introduce some little maths words as I go along. So these people are called, each student is called an X and XI. So this person's X1, X2, X3, X4, X5, X6, X7, X8, X9. It's symbolized by XI. So we'll just write out the mean, so you've got the intuitive understanding. I said it was the total score divided by the number of students. So in math terms, the total score, well, we want to sum them all up together. Sum starts with the letter S, so we're going to use the Greek letter for S, which is sigma. So this just means sum. Sum, add them all together. And we've got to add up all of our xi's. So x1 all the way up to x9. We're going to add up all of our xi's, and we're going to divide it by the total number of students. So here we say n. N just means the total number of students, n for number. So just to write this out a bit more explicitly, sum of xi is really all it's saying is x1 plus x2 plus x3 plus ... plus x9. In other words, add all these together. That's really all that's saying. And n is divided by how many students you've got. So here we see we've got 9 students, because x1 up to x9. And so just divide it by 9. Which is exactly what we did before. Add them all up together. 45 divided by 9 equals 5. Okay. And the special way we symbolize that in maths is called we put a little bar over the x. So that means the mean. X with a bar just means the mean of all of these numbers here. So you can pause it and come back to that later, but I'm going to rub that off because we're going to come back to something soon. Alright, so we've got the mean, and I'll just say that it equals 5. So we can see that all there. Now, just like with the median, the mean's pretty useful, but we can go even further. That doesn't capture how much our data is spread, how much the scores are spread out. And so in other words, we want to find out how much the students vary. So how much do the students vary? If they've all got the same score, they don't vary at all. We'd expect to have a variance of 0. It's just how much they vary. Whereas if some people got 1 and others got 10, we'd expect a bigger variance. So it's just how much students vary. Now the way we need to do this is find out how far is each person from the mean. Because that's how much they vary by. How far are you from the average person? So the average is 5 here. So 1 is 4 less than the mean. So I'm going to write down minus 4. This one here is also 4 less than the mean, that's minus 4. 4 is 1 less than the mean, so that's minus 1. 4 is 1 less than the mean, so that's minus 1. And I'll keep going. 0, 0, because they're the same as the mean. 7 is 2 more than the mean. 8 is 3 more than the mean. And 10 is 5 more than the mean. Alright. So if we're using math terms, what I did was I got each xi, so I got, for example, x1, and I minused 5 from it. 1 minus 5 equals minus 4. So in other words, I got the xi, such as x1, and I minused the mean, which is 5. And just as in a little example there, I went 1 minus 5, and that's how I got minus 4. So that's all this little symbol here means. Get each student score and take away the mean, such as this here. 1 minus 5 equals minus 4. Alright, now I'm trying to work out how much the class varies from each other, but I've got a bit of a problem. If I add up all of these numbers here, they're going to cancel out. These numbers add to minus 10, and these numbers add to positive 10. So if I add them all together, I'll get back to 0. So it's not going to help me at all to find the variance. So to make all these positive numbers, I'm going to square them. So I'm going to times them by themselves. Minus 4 times minus 4 is positive 16. Positive 16. 1, 1. 0 times 0 is 0. 0. 2 times 2 is 4. 3 times 3 is 9. And 5 times 5 is 25. Alright, now I'm just going to see if the video is still aligned. Cool, sorry about that, it's all aligned again. So, if we're doing math terms, what have we done? We've got each of these numbers here and we've squared it. So we've got this equation here, and we've squared it. So whatever that number was, we've times it by itself. As an example, this here, 10 minus 5 was 5, and now we squared it to get 25. Okay, so before we can work out the variance, we need to add all these numbers up here together to get the total variance. So let's do that. 16, 16 is 32, 33, 34, 38, 47, and 25 is 72. So you can check yourself that later, but all of these added up here together, all these here added up together equals 72. And we know how to write the way to add things together. Here with our mean, we said the sum of all of the xi's was the total of all of them. So now we need to say the sum of all of these. So all we're saying is I want to add up all of these numbers here. Xi minus x bar, which is the mean, squared. So let's just go back again. Got each individual result. I took away the mean, I squared it, and I added them all up together. That's exactly what we've just done. Okay, so we're getting really close now to knowing the variance. I've just forgotten the formula for the variance. Okay, so that's right. The variance, so this is kind of the total variance for the whole class, but the variance itself is what you want to call the total variance for the class. Total variance divided by the number of students minus 1. Now we just do minus 1 because you can't vary from yourself. There's some guy who already is the mean, so we don't need to take him into account. Alright, so conveniently we've got the 72 sitting right in here. I didn't plan that, but that works out well. So the total variance was 72. That's the sum of all our values. And number of students is how many? 9 minus 1 is 8. So 72 divided by 8. And that equals 72 divided by 8. What times 8 equals 72? It's 9. So the variance is 9. And what I did there, I got this variance, this total variance here, and I divided it by the number of students, which is n minus 1. So that's the variance. I'm just running out of space here, so I need to rub off the stuff, but you can always pause and come back to it. Okay, now the variance is pretty handy, but there's something that's just helpful for some statistical reasons called the standard deviation. And it comes from the fact that we've already squared each number, so they've got a little bit too big, so we just need to square root them. So what I need to do is say that the standard deviation equals the square root of the variance. Now what was our variance? Variance equals 9. This number is the square root of 9. And the square root just means what number times it by itself to give you the number in the middle. So if you times it by itself, it gives you 9. Pause the video if you need to. It's 3. So the standard deviation is 3. And the way we write that in maths is we added everything together, or we squared everything, added it together, divided by the number of students minus 1, and now we've square rooted it. So this is how we got our formula for the standard deviation, and you've got an example of how to do it. Okay, we're nearly there. I'm just going to rub this off now. So the final thing we might want to do is compare our classroom or our school to another school. Now this isn't to compete for parents who want to send their student to the best school, it's to see that is our assessment not only ethical and valid, but is it reliable? Are our tests reliable across the whole country? So we said that the mean score for my class mean is 5. But if I want to go around the place saying, hey, my school's got an average score of 5, one of the other teachers might say, hang on, you've only tested 9 students, what about all the students in my class? So this 5 might be wrong. So we need to do something called the standard error, which is how much our mean might actually be wrong by in terms of representing our whole school. So the standard error is how much this might be off by. So it was, sorry, I forgot to say this value here came out as 3. They added up to 9, then we square rooted it and it came out as 3, so our standard deviation which has also got the symbol sigma, is 3. So our standard deviation is 3. The standard error is whatever our standard deviation it was, divided by the square root of the number of students in our class. So our standard deviation is the symbol here, is 3. Number of students in our class, 9, so the square root of 9. And we already know how to do this. I'll keep going downwards. The square root of 9 is 3, because 3 times 3 equals 9. 3 divided by 3 equals 1. Alright, so that is our standard error. Now, the importance of the standard error is that it helps us know how much our mean might be off by. So if you times your standard error by 2, you can be 95% sure that your mean is in that range. So we can be 95% sure that the actual mean is 5 plus or minus 2. And that's because the standard error was 1, so we need to times it by 2. Or in other words, the actual mean is between 5 minus 2 is 3 and 7. So now we can go around to other schools and say, we know that our mean score for our students is, we're 95% sure that it's between 3 and 7. So if you went to another school and they were 95% sure that their score was between 1 and 2, then you'll be able to say there's a significant difference between your school and another school. But if there was a different school they were 95% sure that their scores were between 5 and 9, sure, there's a higher, but because these two overlap, 3 and 7 overlaps with 5 and 9, then you can't actually be 95% sure that their school's better than your school, in terms of that test. So I hope that was helpful, and I'll see you in class.